All right, my name is Angel Banchs. I'm with Red Rock Ops, and today we're going to show the process I use to calibrate the Brompton Tessera processor and the LED tiles during a show setup. And what we're doing is we're going to take this tile from a native gamut, and you're going to see it's beyond the Rec 709 sRGB gamut, and we're going to, with the actual Tessera OSCA, which is on-screen color adjustment, we're going to use that first to get the tile into gamut and into show mode so that we can record it with cameras or view it with cameras. And then the second process I'm going to use, I'm actually going to use the Calman 3D LUT generator, and that's going to generate a LUT, and we're just going to pop that in the processor, and we'll see the two different processes and how the LUT generator does such a great job of not only getting the tile into gamut, but also fixing the gamma and fixing a lot of other issues in the EOTF. So let's go ahead and get started. All right, first off, we're going to open up Calman. First thing I'm going to do is I'm going to profile my meters. Usually if you have a C6 setup, we would use one of the presets, but since I have the luxury of having a CR250 spectroradiometer and a Klein K10, I'm actually going to profile this tile. I'm going to profile the K10 to the spectroradiometer. The thing that we're doing here by profiling the tile is making sure that the SPD is matched to the display type. And so that gets us a much tighter calibration. The C6 is provided already in Calman with some presets that we usually, you can even give me a call if you're my customer, we call Calman to see which preset best fits your display type. But I would suggest that you ask or you figure out which display type is the best for your SPD. You don't want to be measuring a CFL bulb type with, say, a direct drive like LED like this, and vice versa. The type of LED or the type of display you're using should correspond to the preset you're using so they get the best calibration possible. So here we go. We're going to go ahead and meter profile my Klein K10 to my CR250. So as in all Calman workflows, we'll start out with what the workflow is doing. We're meter profiling. So let's go ahead and hit this meter profile button. It's going to ask me what meter I have. And so the CR250 sees from ultraviolet to infrared. So it will see all display types. And we also find our source here, which is Portrait Displays G1, which we would go here to find source, Portrait Displays G1, and then we would select our source. We can see that later. The other thing I always do is make sure that our delay is correct so that we're triggering a pattern and then the software knows to read that pattern at the same time. And so we're not sending out red and it's expecting green. So that's the reason we make sure the delay is correct, because systems have delay through them. So there you go. That's why we make sure the delay is set. Let's move on. Right now I'm at 1080p 24. That really doesn't matter. And we're at RGB 8-bit. So that's where our color bit depth is. And let's move on. So I have the CR250. The pattern generator, as you can see, Portrait Displays G1 is on the tile. Just to make sure, I'm going to go ahead and do a read series, and it's going to go through all the colors. And so here we go. You see we have our white point has been set. You can see our red is way out of gamut. This is sRGB we're seeing here. And then green has been red. And then there's something very typical with LED tiles. You see how the blue locus is well beyond or well above the Rec 709 or sRGB locus. So we'll make sure that these two match. This is something that's inherent in the tile, so just want to be aware. That doesn't mean you can't use the tile. That just means you have to be aware when content creators are using this tile, maybe even create a custom color space, which I do often. But let's move on. So in here, we're actually going to add a profile. You can see that our reference color meter is a CR250, and we're going to calibrate the K10. The display type is more like a folder for me. I like to put the LED stuff in the OLED folder, if you want to call it that. I'm going to go ahead and add a profile. I know that this is a row BP2, and I'm going to call it V3 tile. And I'm going to call this Portrait Displays, okay? So I'm going to go ahead and add that profile, and we're going to go ahead and do a single pass. And what it's going to do is we're going to calibrate both meters at the same time as opposed to stopping and then reading again. So here we go. As you can see in the screen, the reference meter says it's busy and the target meter is busy because they're both reading at the same time. All right, so our meter's done. You can see we have good data here. And we're going to go to the next screen. And we're actually going to remeasure this. And so the next screen, we're going to go ahead and see how well calibrated the two profiles are to the actual CR250. So here we go. And as you can see, Blue, we're dead on. We're very close here. Green, we're very close within 1/100ths percentage points, X and Y, and then white. So and also you can see here in these bar markers how close we are to the tiles. Calibration. Then so both meters are now calibrated together. So now the next thing I do is I'm going to be doing a calibration standard SDR manual calibration mode on this, and we will save the data from here. As you can see, I've saved other data. I'm going to call this BP2 and then import our displays. So I know to go back to that, save that. And now Calman is actually going to switch over to our SDR calibration mode. We come up. One thing that I like to do is like to pin this. So I have all my pages or modes here on the side. And we're going to go to same thing. We're going to find our meter profile we just created, row BP2 V3, and then we have our source ready. Let's call that out. We'll go here to port to displays G1, and we'll go next. Nothing on direct display control. We're not directly controlling a monitor, so we leave that open. Next up, we're going to do our targets. With LED, I like to run power, gamma, EOTF, or the gamma at 2.35 because that's what Brompton's sRGB native standard gamma curve is 2.35. As you can see, the color space is Rec 709, and the white point's D65. So we'll leave all those targets together. But if you see here, you have many different choices, D50, D55, and then DCI white point. And you can also do your custom, which is something we can talk about in class if you ever come take a class with me. But here we go. We're going to do our pre-cal calibration so that we can see what how our tile is responding before we go do OSCA on the actual processor. So I like to run this in ITP mode. This gives us more resolution when it comes to the luminance depth. And also we're going to see RGB balance. And one thing that I do is I put it in 11 point because we read things in 10 steps here instead of 21 points. So that way it gives us 0 to 100, and that's 11 steps. And here we go. Let's do a read series. As you can see, we're pretty decent by just looking at the red here. We can see that the light in the room is a little bit cooler than what we want to be. So there's white, and then there's red, green, blue, and then we have our secondaries, cyan, magenta, and yellow. So we have some calibration to do here, but with the Brompton system allows us to get very close. So let's go to the next screen. And here's going to be our CCT, or our correlated color temperature. This is where I'll pull out the meter and talk to the lighting director, but here we're going to see what the color temperature is right now currently on this tile, and we're at 4,800 degrees Kelvin. We are going to be shooting for 6,500 because Brompton standard is 6,500 gamma 2.35. So let's go ahead and go to the next screen. I typically bypass this, but I'll just show you. This is just showing you how the gamma is of the CCT is rolling across the entire spectrum here. So we all see we're in the 4,800 realm. And then we're going to go to dynamic range. Now, this to me is the most important part of this entire process is dynamic range, and I'll show you why. So let me go ahead and do a read series here real quick. And if we have, all right, this is perfect here. That means our dynamic range is not set correctly. What we need to do here is we need to make sure that this line tracks completely through. And the reason is we have full range and full range and reduced range. And I can explain that to you later, but reduced range means that your signal in an 8-bit curve stops at 16 on the brightness side, so black. So anything under 16 will show as non-chips. So if I had the full range here, I would see chips all the way. And what I mean by chips is the actual black patches that are going down. So if I show you here in brightness, as you can see right now, there's a 16 chip that's red. It's kind of hard to see here, but we can show it later. And then in contrast, above 235, there should be chips that are differentiated all the way to 255. And maybe if you can't see it here, we'll show a graphic on the screen on exactly what that is. But what I'm going to do is I'm going to change the mode on my G1 pattern generator. See right now is limited range. We're going to go to full range, and then you should have seen a change on the tile. And now you can see there's different swatches. So let's do that again. If I go back to reduce range, you can see that the patches go away. And if I do full range, you can see that we have full dynamic range now. Boom, there they are. You can see them along here, right? So now let's go ahead and reread, and we should have a nice straight line. And again, these are all things that we teach in class, and we'll teach it in depth. So I just want you to know that this is a quick calibration for this. So we're going to move on to luminance. This will be very important when we're doing a live show to see what luminance, what luminance we're doing. So we usually want to translate foot candles to luminance. We are screaming here at 890. Usually on a show, we would be somewhere in the 300 range. So we would bring that down. But since we have studio lighting here, we're kind of fighting that. For this case, 890 will be perfect. Let's go next. Our white balance, we know we're going to be off because we're at 4,800. And Calman right now is calibrating for 6,500 or D65. So we're going to see that we're off. We're going to have a little too much red and a little too little blue here. So this tells you the white balance. Let's go ahead to the next screen. And then multi-point grayscale, this is what the grayscale or the gamma is doing across the range in our tile here. So let's go, I'm gonna go to 11 points again, that's my favorite. And let's go ahead and do a read series. We're gonna see across the spectrum here, how far off we are. In other words, if I'm putting 20% of gray in, am I getting 20% of gray out? Right now, if I put 20% of gray in, I always read the center, which is, center would be green to me. I'm getting about 105%. Now this particular screen here, it auto ranges, so don't worry about it. And we can see we're a little deviated, but not bad. It's looking pretty decent. And we can see here on the EOTF, we're just a little bit separated on black, but Brompton has gamma curves, so we're gonna fix that in just a second here. All right, let's move on to the next screen. And then I usually pass this up and I'm gonna go straight to color checker because we're short on time here. Now, we have the ability to show all kinds of patches on screen, but what I want to do is I want to go here to the basic workflow and I'm going to turn off black and I'm going to turn off Color Checker Classic, which is a product that allows you to check color in photography, but we're strictly looking at saturations here. So let's go ahead and I'll call this going around the horn, and later we're going to play golf and I'll tell you what that is. So let's go ahead and read this tile. Right now, one of the cool things about Calman, if you hold the mouse over the target, you can see how far off we are. If you look at the actual and target, so the actual right now looks a little bit warmer, and we're at 4,800 from 65, so that is going to look a little bit more beige or cream. And then you can see where our points landed all around here. So let's go ahead, and now we are going to go to Brompton's Tessera software here. And we're going to go to the Tessera remote, and we're going to go ahead and split this. And I'm showing you the software here. I'm going to break this over so I can see Calman on this side. It's going to look a little bit smaller, but nevertheless, we'll still be able to see what we're doing. And as the Tessera software loads, we are going to show you what's going on here. So here we have the Tessera remote software, and we can see we have one lowly tile right here. So we're going to see what we have. As far as we are going to assume that this tile doesn't have Dynacal calibration, and we're going to go do the on-screen color adjustment, which is called OSCA. And Brompton has always allowed this for us to have to use to calibrate tiles natively. There's also Dynacal. If we hit here, this button, Dynacal also shows us a 1931 chart. And then here you can also choose your different color spaces, and the tile will conform to those particular color spaces. What we're going to do here is we're going to go and do it as if we didn't have any Dynacal information in the tile, and we're going to show you a couple things here. Now, one thing that I like to do immediately is my LCH direction, and this is something you can actually set in your workflow properties. We can actually save each one of these workflows to our liking. So the things that I'm going to set right now, I always leave it so that I can show students what I'm doing, but I'm showing this direction from the middle, and I'm showing that it can go up or down, because otherwise what happens is as we start getting closer to cal, it goes to 0 and it goes away. This way it tells me whether I'm the center or out of the center. So let's go ahead and set all three of those, and I could save that as a workflow for myself, but I keep it like this so I can teach you instead. So here we go. We're going to go into OSCA, and the screen's going to turn white. And what we're going to do here is let's go, and we're going to go ahead and calibrate white. But what I'm going to do is going to go in the tab setting here and allow for the tile to show not the internal pattern, but the full pattern. So here we go. All right, so now we're measuring all the colors in the tile. So I'm holding tab right now so that we can see what the actual input of the Brompton is seeing. And here we go. So we have everything's just a little bit off. So let's start working. This is where we're going to play golf, and we're probably going to forward through this on the tutorial, but I'm going to show you what I'm actually doing here to see what we've got going on in the Tessera processor. And unfortunately, I have to cover up some of these, but here we go. I'm going to go ahead and hit white, and I'm going to go white here. And I'm going to put this meter in continuous read mode. Now, one thing you want to take a look at is right here. You see how this white indicator is almost like an LED on the program. It's telling you that the processor is reading or that the client is reading constantly. And here I'm going to go choose white. And what we're going to do is we're going to go into F7 mode. I'm going to choose all of the quadrants. This is the way we do this manually, because on processors that don't have the kind of color handles that Brompton has, you'd have to do this manually. So that's like to show that it really does make a huge difference. We know we're going to be reading white, so we're going to start getting white right into the center. So this is what we call golf. We're assuming that this little white dot is our golf ball, and we want to put it right in the hole there. So I know I need to put, let's see, A, and we're going to go tab here, and then I'm going to start taking some red gain out, and you'll start seeing the red come down. There's the red. I'm holding control, getting a little bit more control of my signal. You can see how fast that's happening. And then we're going to turn blue gain up. And there goes the blue gain. And as you can see on camera, it's going to start getting 6500-ish, but we're calibrated to different lighting in the studio, but we're going to go there. So what I'm going to do is I'm going to first calibrate to 6500 because that's the Brompton standard. And what I'm doing is I'm calibrating the slider. Okay, so we have our white is out, it's done now. So I'm going to click here, and you see how there is no line here now. That means we're calibrated as perfect as possible. All right, let's go on to red. We'll kind of do a speed calibration here. Let's move to red. I'm going to go red, and then we'll go red here. And as you can see, we're going to take some saturation down. You can see saturation coming in. And we're going to move some hue over. And here we go. Oh. Move hue, saturation out. We're going to play golf on here. There it is. Beautiful. And Brompton gives you this kind of control, and it's incredible that they allow this, where to other LED manufacturers do not. So one of the reasons I'm a real advocate. And the last thing we need to do here is get luminance. So bring that luminance down a little bit. So we're to the standard. Here we go. As you can see, luminance is coming down. We're almost there. All right. And by TV magic, you're going to see this happen, and it's going to be, we'll probably just only show this one, but I'm going to go and calibrate everything else for you guys, and you'll see it calibrated. So on blue, this is something that the blue on most LED tiles, and this is an older LED tile, it's very hard to calibrate because the actual luminance in the actual SMD do not qualify with Rec 709. So what we're going to do here is we're going to try and get as close as we can to our calibration, but most likely we won't be able to get very far. So that's no big deal though. It's still, rest assured, it's still going to look pretty good. So let's move our hue here. And I think that's all we're going to do with that. Moving on, we'll go to cyan. I'm going to go cyan here. And that's a saturation thing. And again, this is for tiles that don't have Dynacal available. We would have to do this manually. Usually most tiles have Dynacal available. I just want to show you how Calman not only is so responsive, but also it's got the ability to get you right where you need to as far as color gamut goes. So we're curtailing this tile sRGB. We're going to go ahead and rec the luminance up, get it right where we need to. All right, almost there. So now, as you can see around the horn here, other than blue, because that's an actual physical thing that can't happen in the actual pixel. Oh, we still need to do luminance here. We'll finish off with luminance, and then we're going to go and see how well our gamma is doing. All right, so let's go ahead and I'm going to go ahead and export this. I'm going to right click, and I'm going to go ahead and just select one module. I'm going to export this. I'm going to call it D65G235 for gamma 235. That way I know what's in there. And let's save it to the desktop. Boom, there it is. And then what I do is I would highlight every other tile on another processor and copy that over. And so we're ready. We're done with this. I'm going to say OK. And so now we'll get rid of this, the processor for now. And one thing I wanted to show is a Calman family on there, which is in the skin tones tab. And there you go. So I don't know how this is looking on camera, but now you can see that it's pretty accurate. Obviously, we're seeing a 4K display in 128 by 128, so it's going to look a little bit off, but rest assured it is calibrated. So the next thing we're going to do is going to work on our gamma curves. So I'm going to go back to our multi-point grayscale, and we're going to reread that. Now we're going to see that these three lines are going to be they're going to be tied together because now we're within the 6500. So here we go. There we go. Much tighter together. Tracking through. Now the only reason we have this separation here is because I'm a little bit off from the screen. I could be right on the screen and then that would be completely black, but we have a light right here just because we're shooting. But as you can see now, we're tight all the way through. Now, one thing we're going to be able to do with the Brompton is we're going to work on this 10% stuff here. So we'll go ahead and get that into continuous read mode, and we're going to go to our curves dialog here, and then here we go. We're actually going to move this. I'm going to put a point here and a point here. I'm going to start bringing that down. As you can see, that comes down. That's how much. And then let's go ahead and read this and see where we're at. This is the kind of control Brompton gives you. This is incredible. It's like, I can't tell you how cool this is. Well, actually, I'm telling you how cool this is. Just kidding. And then so we're going to go to, all right, we see there in the middle, we have a little rise at 50%. So I'm going to go ahead and start reading at 50 and bring that middle part down a little bit. And you can see it in real time over there. Oh, if I put that to read, whoa, went too much, and come back in a little bit. There we go. Very nice. Yeah, I think that should be it. Let's go ahead and reread. All right. So you can see what's going on with the curves and everything else. Basically, a direct curve here in the middle is a win for everybody. So I might need just to tweak just a little bit more over here. I'll read it one last time. And that'll be considered a calibrated tile. What I'm going to do right after this is then we're going to employ the LUT engine. There we go. It's looking better. And of course, with a little bit more tweaking, this would be done. We're doing this manually, okay? So now what we're going to do is we're going to clear everything out we just did. So we're going to go ahead and rewrite the curves. We're going to go here to Oscar. And then we are going to take our tiles. And we're going to, actually, I'm just going to go ahead and reset the entire tile back to normal. So I'm going to right click here and we're going to reset the tile. So now we are going to employ the 3D LUT generator in Brompton, but we're going to first go ahead and create a 3D LUT in Calman. So we're going to go ahead and close this profile by going to, I'm just going to go to the calibration 3D LUT profile. Do I want to save this session? No, not for this. And then what that would do is save all the data and the histories and everything else if you want to go back and talk to a client or show them how things have changed. So here we go with 3D LUT only. That's what I'm going to do. We still have that same profile, the row BP2, V3, and our portrait displays G1. And then we're going to go next here. And then same methodology here. We're going to go to power. And we still want to calibrate to 2.35 gamma, which is sRGB standard according to Brompton, which is fine. And then go next. And we're going to do a pre-cal calibration, just showing us the state of the tile right now. So I'm going to go back to my 10-point and ITP here. Again, you can save this as workflows, but let's go ahead and do a read series. As you can see, we're separated again. We're at 4,800 and we're shooting for 6,500, so we're a little bit warmer. So you're going to see the red channel is a little bit hotter, right? Because it's a little bit warmer. So, and then we can see how far deviated we are from white over here. This is 6,500. This is 4,800. And we can see how far out of gamut we are here. Now we told Calman in the in the calibration targets what color space we wanted and what gamma we're trying to follow. So we're going to go next here. We're going to skip right through the 1D LUT calibration, but we could do that if we had a 1D capable system. But we have a 3D capable system. And now this is the important part. So now in direct display control, we're going to go ahead and employ the 3D LUT. So we're going to go ahead and find that display. We are going to go down to portrait displays. We're going to go find our cube generator 3D LUT, and we're going to connect it. And as you can see, it shows up. Now, the way I calibrate these, I go to 31-point SMPTE extended. We're going to do a 33-point LUT, which is what the Tessera wants, the Brompton Tessera wants. And then we're going to go to the dot cube common formats right here. Okay, and then I'm going to name it BP2. Okay, and then we're going to go ahead and save that. And let's go and hit our auto cal button. It's going to read the tile. It's going to tell Calman where it is. This is where we set all our stuff. 16-bit depth, 33 points, cube format. Delay is going to be 1 second. As you can see, that first read that it did, it tells you how fast it's going to read it, 0.18 seconds, but I'll leave it at 1. And then we have, right here is the LUT type. For this demo, I'm only going to do a lightning LUT. Lightning LUT takes and reads points and then averages out which points need to change. And it does about 101 points and a 26-point ramp in about 5 minutes. So I use the SMPTE Plus 16 to 255, 60 SMPTE extended. But there's other methods of LUTs that you could use, like IR time-based and IR point based. So you can tell it to go ahead and do a 4,000 point LUT if you wanted to. That'll take about 2 hours, or you can do a time based. You can tell it to calibrate as much stuff as you can in half an hour or an hour. So, and then there's all these other grid fixed grid 9, 13, 17, 21 point, and matrix LUT. So we'll discuss that in class if you take a class with it, or we can go to the knowledge base and find out what those do. So let's go ahead and do the calibration. So see you in 5 minutes. Here we go. So now we're finished reading all the points here. You can see it's rescaling the profile, and it'll go up to 20,007 points. That's going to update the cube generator. And then we're going to go ahead and put that LUT that it generates directly into the Brompton software. It's going to be that .cube file. All right, so we have our 3D LUT calibration completed. It tells you how long. It took 4 minutes, 38 seconds, and it read 101 reads, and then it did its magic in the background. So we're now going to go find where that 3D LUT is, and we're going to hit this. I'm going to go to the cube generator. I'm going to hit this little button here, and then right here is the BP2. I can either copy that or know where it is, right? So I'm just going to copy and paste it in the desktop just because we know where it is. Here it is. And actually, there was a copy already saved here, but that's fine. So now let's go to the Brompton software, and we're going to go to the 3D LUT section of this. Here's the 3D LUT. I'm actually going to turn off the curves because we don't need it anymore. We're going to go ahead and click on the LUT tile, and we're going to go browse. We know it's on the desktop, and there it is. And as I turn it on, you should see the tile change. And so one thing that Brompton does is you can actually ramp the LUT up and down. You can see it on your screen how it's moving as I ramp this up and down. And then let's go ahead and measure that in Calman. Let's go do into a post-cal capture in Calman. Again, I'm going to go to 11 points. And again, you can save this in a workflow. So here we go. We're going to do a serious read and see what happens. Okay, now one thing I wanted to show you is it seems like this is separated here, but this is an auto ranging space. So you can see now to where before we're at 110% out, we're at only 102. So we're like less than half of a percent off here. And then look what happened to the gamut on the tile. We are very, very close now. This is just by one pass LUT, and also look at the EOTF right here. And again, this is if I right click on properties, you can see this is auto axis. If I go fixed, you see now how tight this is. Basically what Calman's doing is it's trying to give you the most resolution possible. So when you put this on auto axis, if I do this, see how it blows it up to, basically we're within 1% off of 100. This is incredible here. And then we're just a little bit more saturated on red, but everything else is falling within the dots. Of course, blue is not going to be there, but this is 5 minutes. And now we have a tile that's about 90% calibrated. It's gamma correct. And now let's go ahead and put our family up on the screen. Let's go gray steps there, and let's go back to skin tones. And there you go. We achieved the same thing we did with about 25 minutes, which I was explaining usually takes me about 15 minutes to do that manually. But here you go. The Calman LUT engine did it in about 5 minutes, maybe 7 minutes by the time you hand it to the LED guy or gal. And then there you go. Pretty cool, man. That's the power of this LUT engine. Now, just think about that. Now you have the tools. It's almost like you have a multi-tool to generate LUTs for anything. It could be Atomos screens, Flanders screens, anything that takes a 3D LUT. Here in our RS4 as well, we're going to show another demo of that. And there you go. That's the 3D LUT engine. I hope you enjoyed this. And have any questions, ask the folks at Portrait Displays, or have them forward some questions to me. So thank you so much.